Hello everyone, welcome back. So today we are going to talk about Azure system design and the ingestion part of it. So last day we solved a very simple Azure design system question from scratch, step by step, and in the steps we talked about ingestion, pre-processing, transformation or processing, and finally storing the curated data. So today we are going to talk about ingestion in details and the different sources that are there which can be ingested in the Azure landscape. Okay, so let's get started. So these are the sources generally which we work on when we want to ingest into the Azure landscape. So we have APIs, we have different kind of on-premise or relational databases, we have streaming sources like Kafka or other streaming sources, and we have different file systems. It can be SFTPs, it can be SharePoint locations, and we have different applications as well, like MuleSoft application or MFT application, anything which can be brought into the Azure landscape. So first let's talk about APIs. So in API ingestion, what happens is it's usually stored in a third-party location, and the API usually returns a JSON or an XML file, and we need to bring that data into Azure. So the most common approach can be that those usually are the REST APIs, and ADF, which is the orchestration tool or the ingestion tool, it can consume that with the linked services, creating the linked services, and then we have the copy activities as well. And as is, it can bring the data into the landing zone, which is the ADLS Gen2. So how will it work? ADF will call the API, it will authenticate it, it will create the passcodes and the tokens to authenticate that the API is valid or not, and finally copy the response into our data lake, and then the data will be copied fine. But the real world APIs, they come with challenges. So we may have pagination issues. So pagination means that it can only not be one page, it can have multiple pages, it can have rate limits, it can have authentication issues, it can have retry issues or incremental data requirements. We'll go into all of these into details, but just consider it as some limitations which real world APIs can have, because usually it consists of a huge amount of data since it's a source data. Okay, so instead of pulling every order or every data every time, what we can do is we can use something like a timestamp column and only retrieve the records that has changed since the last successful run. So this again comes to the incremental form of data loading or ingesting that we talked about in the last video. And the most important point is that API ingestion isn't just about connecting to an endpoint. We also need to think that how efficiently we are extracting the data. Okay, so let's say that in a JSON we have 1,000 records. Okay, so today the ADF has connected to the API source and it has brought the 1,000 records. Now we want to see if we want to bring all the 1,000 records again tomorrow, or we want to overwrite it, or we want to only bring in the new records which has come from the last successful run. So what we want to store into our Azure landscape and how we want to design it totally depends on that. So if I am working with APIs, what I would want to do is, if I've already brought in those 1,000 records, it is stored in my table or the ADLS Gen2 folder. I will only bring in the new data. If it's 1 record or 2 record or 100 records, I would only bring in the new records which has come with the timestamp again. So if the 1,000 records were yesterday's timestamp, it will check that whatever has come greater than that timestamp, those only will be hitting the authentication and everything, and those records will be fetched from the API and brought into the ADLS Gen2, the Azure landscape. Okay, this is one way you can design it. The second way you can design it, which we call as the snapshot loading. Okay, so snapshot loading is basically you bring everything today and then tomorrow you basically truncate and load. You truncate everything and load everything that you have at that point. So it's basically taking a Xerox copy, taking a snapshot of the system at that particular time. So either way works. But when we are bringing to ADLS Gen 2, as in the last video also we discussed, it's basically for our traceability, because for the Azure system we are building things from scratch, right? Because we do not want to go back to client and to the source system telling again and again that we have lost this data. So we want to store historical things in our system also. So it's better to keep the traceability and store whatever is possible with timestamp and all possible details starting from the first layer itself. Okay, now the second part of the API ingestion is that where if the API is not straightforward, right? If the API requires more custom logic, then what we need to do is we need to have our own logic written with functions. It can be any programming language, Python or .NET or C also. I believe Azure Functions support C++. So in Azure, there is a service called Azure Function Apps. It can be a better fit. So what happens is you have the API and you want to apply some logic. So for example, the API is hosted in an application. Okay, so the application, how it works is, let's say the user inputs something. Let's say the user uploads a file somewhere by clicking a button, which we often do, and they upload the attachment and they click on upload, right? So where does that file go? That file has to go somewhere, right? So the file in our case has to store in ADLS Gen 2. It has to come from that application and come to ADLS Gen 2. So how does that link happen? So that link will happen through our function or the code that we will write in Azure function. So the Azure function, what it will do is it will connect to the application's backend, trace the location where the file was stored, bring the file from there and connect to the ADLS Gen 2's endpoint and store it there. So the Azure function has to be written in such a way that it does all of this thing in the backend. Okay, and in that case it will be a better fit, because it totally depends on the logic. If it's a straightforward API where you do not need more complex things, it can directly be done with ADF. If it does need more custom logic or more complex mechanism, then Azure Functions is a better fit. So basically Azure Function then acts as our custom code layer. It can call the API, handle the response, apply the custom logic, and finally then it will write the data to our storage layer. So storage layer in this case is ADLS Gen 2. Okay, so the important thing is to say that like what to use, ADF or functions. It is not the important thing. What is important is to understand that when and what time or what requirement or what scenario, what makes sense. So ADF is an orchestration and standard data movement. Azure Functions is custom code and API logic. Okay, so at times you can use both. So ADF, inside ADF also you have the convenience of using Azure Functions. So you can write your custom logic, handle the API, and then you call that Azure function from ADF, okay, to orchestrate it. So you can do it either ways. Okay, now then regardless of which approach you choose, real world APIs of course always brings challenges, like pagination is there, rate limits are there, we already talked about it, and incremental ingestion is also there. So depending on the scenario and depending on the requirement, we will need to slide it down. Okay, so if it's a standard ingestion, we will use ADF. It's a custom API logic, we'll use Azure Functions, or we can incorporate the Azure Functions inside the ADF as an orchestration and then land the data into ADLS Gen 2. Okay, so this is about API ingestion. Then coming to database ingestion. Okay, so database ingestion is pretty straightforward. It can be an existing SQL server or PostgreSQL database or Oracle database. It can be an on-prem database, anything. So Azure Data Factory is like the very suitable and the easiest connectivity and connection available. So you can directly connect to the endpoints of the database host name and the URL wherever the database is hosted in, and the destination will be your ADLS Gen 2. So all this infrastructure can be set up So now there are 2 points to it. Either you want to perform a full load where you copy the entire table, but if we are dealing with millions of records, every day doing a full load isn't efficient. So at that time, we can do incremental ingestion. That means, as we talked earlier also, right, there can be two things. Either we do an incremental loading where you only take in the newer records after a particular timestamp, and or you do a snapshot loading if the number of records is less. So in this case, if we are dealing with millions of records, what we can do is we can have an updated at or a timestamp column which says that this is the time when the records were ingested, and the next time it runs, it will just check that the last successful time when it was ingested, it is greater than that. So in that case, it will only fetch in your new records. So now the question lies, do I need to do a full load or incremental load or a change data capture? Okay, so let's go deep down into it. So full load is basically when I'm ingesting the data from our database or data platform. It depends on the data volume, the frequency of the ingestion, source capabilities, and how frequently the data changes. So what happens in full load? A full load basically means copying the entire source table every time the pipeline runs. That means a source table, if it contains 1 million customer records, and every pipeline, so if it runs 5 times a day, that means it will run, every pipeline run will extract all the 1 million records every time. Okay, and when should we use it? So basically full load should only be used when the table is relatively small, the data doesn't change frequently. For example, we should be having it, if we are running it every quarter, we are having a full load refresh every quarter or every 2 months or something like that, which is basically the one-time loading, or three times a year, something of that frequency we should be doing a full load. Okay, and this is an example for that. So let's say there's a table called country master. It contains only 250 records. So if we do a full load once a day, that is perfectly reasonable. And there's a little benefit also in building a complicated incremental mechanism for such a small data set. We do not need a incremental mechanism, like we'll have to add newer newer columns to understand when was the last updated data, and then we have to understand if we want to do an upsert or not, if we want to do an insert or not, if we want to merge the records or not. So doing that on a small amount of data doesn't make sense. So full load should work totally fine. But as the table grows, full load becomes expensive. So that's what. So if we have 500 million records and only 10,000 records change every day, then copying all of the 500 million, it's wasteful. So that doesn't make sense for full load. So to conclude, full load can or should be working on a small data load, or when the frequency of data changes, not that higher. Okay. Now let's talk about incremental load. So with an incremental load, we only extract the records that are new or have changed since the previous successful ingestion. So updates and inserts. So you can talk like upsert. So only records that are new, that means new inserts, or that have changed since the previous successful ingestion, that means updates. Okay. We already have talked about this. So previous watermark column it will check and then extract those changes, load it into ADLS, and once the data is loaded, it will update the watermark column, the timestamp, and then again the next day the same thing will happen. So if they ask you in the interviews that design your database ingestion, so immediately let's not say that I'll use ADF. Okay, so there should be a well-structured answer to it. So ADF is basically the ingestion of the orchestration tool, right? But first we have to decide that how am I going to identify the data that needs to be ingested. So first we'll need to think about, should it be a full load, should it be an incremental load, or should it be a CDC? CDC means actual database changes, that means including deletes also. Okay, so once we have a good idea of this, that what it is going to be, then we can design our ADF activities better. Okay. Okay, so is it going to be a copy activity, and the copy activity, is there going to be a pre-copy activity, is there going to be a script which will run before the copy activity will happen? All of that will decide based on this thing. Okay, so now we'll come back to file ingestion. So the next common source is files. So maybe a vendor will send us CSV files every morning, or they can put it through SFTP, or directly they will put it to blob storage or any other storage system. So ADF also works efficiently to move those files into ADLS. You just have to build the linked services where you connect to that exact storage and the endpoints of it. So for file, the challenges are slightly different. So we should be asking questions that, has the file arrived? Have we already processed it? Is the file empty? Does it have the expected schema? So the schema evaluation is very important in file ingestion. How many records were received? So even at the ingestion stage also, we need some basic audit and metadata tracking, especially for file ingestion. So for example, file name, ingestion time, status, record count, these can become extremely useful when we are troubleshooting during file ingestion. Okay, because when we are bringing into ADLS for files, if we have files of the same name, right, it will overwrite it and there are chances we'll lose it. So we basically need to keep historical evidence of the file arriving. Okay, so we should be using some date time naming to convention to just track the file, and then the timing, and then the schema evaluation should be there. We should have the raw folder, or the basically the landing zone that we talk about, to say that okay, this is the raw file, and then should go to the pre-processing stage, like that. So file ingestion can have these drawbacks, and we should be solving them efficiently. Next, we are coming to streaming ingestion. So the requirement is completely changed over here. Previously, it were all batches. Streaming is basically the application is generating thousands of events every second. Okay, so it can be Kafka or any streaming application. So customer clicks, transactions, application events, any IoT data, it's having like every second. So we do not want to wait for a batch pipeline to run every few hours. We need streaming ingestion in this case. So in Azure, a common service for this is Azure Event Hubs. Okay, the architecture for this could be, so whatever the application is, we are going to use Event Hubs. We are getting it configured to connect to that application, the source application. If it is Kafka, the Kafka will produce the streams and Event Hubs will consume it, and then Event Hubs will connect to the Databricks landscape or the ADLS, and the data will be received. So Event Hubs handle the ingestion of very high volume event streams, and downstream services can consume those events for real-time or near real-time processing. Okay. So now we have a very clear distinction. Batch sources might use ADF, streaming sources might use Event Hubs. Okay, so the ingestion pattern totally depends on the source and the latency requirement, the frequency requirement. Okay, so let's see the architecture diagram. So for API, it can be ADF or function apps. Then for database, it is ADF. For file, it is ADF. For stream, it is Event Hubs. And everything comes to ADLS Gen2, or in some cases, you can directly bring into Databricks also. Or you can bring it to Synapse also. It depends on how the architecture is being designed. Okay. So let's go to interview takeaway. So if in any system design interview, you're asked a question, immediately do not start naming Azure services. First start asking that what is my source? Is it an API, it is a database, or it is a file, or it is a streaming? How much data am I dealing with? What is the latency requirement? Do I need full loading or incremental ingestion? What will happen if the ingestion fails? Once you understand what is the scenario behind the hood, choose the right services and try to understand and visualize the entire thing which is happening, so you can design the architecture in a better way. Okay, so this was all about ingestion today. in the next video we'll be talking about pre-processing, that is what is going to happen when the data has already landed in the ADLS Gen2 in the raw folder. From there, how we are going to take it to the transformation folder and what are the things that we are going to do to clean up the data. So thank you for watching my video. Please follow my channel and do share it with your fellow colleagues and your friends. Thank you.